Hey everyone, this is Mike from IOpipe. I am our senior site reliability engineer that keeps the lights on for our application infrastructure in AWS. Today I'm going to take you through a Lambda troubleshooting session that happened during a customer-facing robot bingo game. This is what we ran during the keynote for the AWS San Francisco Summit. Some background on the game. We decided to have some fun with the keynote and developed an application over the course of 24 hours or so that would leverage the AWS Lambda and the new AWS Transcribe services. Users would go to https://robot.bingo, click play game, and would receive a randomly generated bingo board based on a compilation of key tech words used in most AWS keynote events. We had a Lambda that would send the audio data to the transcribe service and take the transcription results and put them in an S3 bucket. Another Lambda, which was the main customer facing portion, would then take those results from S3, populate a list of words that matched our master list, and then autofill in the player's boards. When a player hit bingo, they would then tweet out to our robot bingo Twitter bot with bingo, and it would trigger the Lambda to start game 2, reset the user's board, and begin a new transcription list. So the day before the event, while we were doing the development work, we decided to set the Lambda to check the transcribe service once a minute. My ops brain from here wanted to set some constraints in case the Lambda did anything other than that. So I set up some alerts inside my IOpipe project to alert me if the transform function ran more than 15 times in 5 minutes or it had any errors. This allows for some retries in case of any timeouts, but if the function was having issues, it would let me know. So the AWS keynote kicked off around 9:30 a.m. and our system was running normally. As you can see, I'm scrolling through the time frame. Everything looks fine. This is exactly what I wanted to see. During its peak, we had about 200 players during the first game. We had our first winner right about 10:19 a.m. in the morning. That person then tweeted out to the robot, bingo robot, with the words bingo, and from there that we noticed all the boards transitioned successfully into game 2. During the second game, however, I very quickly got an alert that my robot bingo Lambda had run more than 15 times in 15 minutes. I logged into my IOpipe dashboard and clicked into the project, and this is what I saw. If I scroll down here, you can see that definitely this bingo dev transform is in an alarm state. To begin the troubleshooting, I decided to jump into a lower level function view. What we were looking at right here is a top level function view. So if you had multiple functions, you would see them all listed here. So as I clicked in, I took a look at just the pertinent information. I see it ran 36 times in the last 15 minutes, the region that it's running in, the alarm status, how long ago the alarm started. And if we scroll down, we start seeing some more detailed information on what's going on with this specific Lambda. As you can see here, it's starting to take off in terms of what's going on with the amount of functions that are being run. If we take a look over on the right-hand side, though, you can see that the duration of the function was fairly flat. And then as we transition into that second game, we started getting spikes. And you can see that the 99th percentile is starting to get pretty far up there. And as we scroll down, we can see all of the individual invocations that did run. So one of the first things I wanted to check for was to see if there was any legitimate error traces. So if I sort by error here, I didn't see any in the specific time frame that we are in. So I uncheck that and I go, well, let's take a look at the long running durations because we know that the 99th percentile, the outliers were going pretty far out there. So if I sort by duration, you can see this 1019, 1021, right around the time that the issue started, that we had some long running functions. So if we click into the functions, we can see what's going on. So now that I click through to the individual invocation view, we take a look at all the various information that's provided. On the left-hand side, you're going to get all the various AWS information, which would be things like the ARN, what triggered this Lambda, the region, various information like that. This middle column right here is very important. This is the trigger itself. So auto-magically, we collect all of the info from any trigger that triggers a Lambda. So this is our event info plugin, and this provides a very good way to understand where the information that this Lambda is processing or using came from. And so in this case, it's S3. You can see it was object created put, any of the IDs, the bucket names, these types of things. And on the right-hand side at the top, you can see we have the underlying container information. So we see the memory usage. Was this a cold start? In this case, yes, it was. CPU usage, system resources, and various things like that. The next plugin that I'm looking at, this is where I instrumented my code. We take a look at the IOpipe tracing plugin, and you can see we have 4 different functions inside this Lambda. They're running at different timings, but you can see this gap at the beginning. That's evidence of a cold start, because that's just the system resources in the container spinning up to fire off this Lambda. So that's indication number 1. If we scroll down, now we see this custom metrics field. The custom metrics field is very important to me because I do a lot of different instrumentation, a lot of different types of information, responses from various AWS services, and in this case, what the game is running, which is the current game ID, and what items were retrieved by Transcribe to mark people's bingo boards with. Right off the bat, this should never be empty. There should always be something returned. So that was a huge clue to what was going on. And just for comparison's sake, I pulled up a function that was running correctly, and this is after we actually fixed the issue, but I just wanted to show you a comparison of what would be returned through a custom metrics field. In this case, the current game was 3, and the various items that came back that are going to be marked off on people's bingo boards. So back to one of the non-working functions. In this case, this is an area of Lambda that gets kind of hard to troubleshoot sometimes. It's that case where the function ran successfully in terms of how AWS sees it, so it's not going to return an error, but the code logic is wrong, but still successful. So those are really the hardest ones to troubleshoot. So in this case, because this custom metric field right here was empty, I very quickly identified that it was a code logic problem. I engaged with our lead developer, Corey, gave him this information, and he was very quickly able to identify an issue inside the code. However, in this time frame, right around 10:26, we had our first player actually tweet out that their board on the second game wasn't filling even though the transcribe words had been picked. So we needed to reach out, let him know that we had an issue and that we were very much working on it right now. So Corey did get back to me very quickly and said he had found the issue, fixed it, and was getting ready to deploy. So just a little code snippet. I'll show you exactly what we fixed in the code to resolve this issue. So looking at the code snippet, this is actually a PR that we sent up to fix the issue. You can see on the left that we were not iterating the game to update with the new transcribe. So we were able to very quickly add the iterator in there with the new game ID, submit this PR, get it approved, push it through the CI pipeline, and push it out to the players. So we sent the PR up into the infrastructure right around 10:31. Right after that, you can see the game resumed as it should normally. We had all of the players refresh their board via a tweet, and everything went smoothly from there on out. So the time from 10:26 when we got the first customer report to the time we deployed the new function was about 5 minutes, but we'd already been working on it for a short time frame before that. So the median time to resolution was about 12 minutes or so. In the end, it turned out to be a runaway function that was going to get exponentially worse unless we had the tools to report the issue and then the team to fix the issue in the end. So you can see from here we were working fine. The function starts running away. We deploy the fix. Everything's fine and dandy after that. It's definitely one of the worst issues to troubleshoot without having tools like IOpipe. Just because it's very hard to understand what's going on from a code logic perspective. So instrumentation of the code is extremely important, especially to me running the infrastructure. I need to look inside the black box, need to understand what the code is doing, when it's doing it, how it's doing it. And so using IOpipe really helps me in those situations. I definitely love dogfooding our own product, and I run it in our production environment that runs 200 million invocations a month. So I love it. Hopefully this helps anybody else out who's trying to troubleshoot Lambdas. If you have any questions or any comments or anything like that, please feel free to reach out to me on Twitter, or you can email me directly here at IOpipe. Definitely willing to help. If you want to try out IOpipe, just visit the website. We have a free trial where you can get all these functions and all the advanced plugins. So everybody have a great day, and thanks for stopping by and watching my video.